In this video, we're looking at an introduction to density problem solving using unit multipliers. This is aimed at grade 9 advanced science or perhaps a grade 11 chemistry level. If you're doing grade 9 advanced science, you'll want to have with you perhaps your solubility chart, or if you have your science booklets, you can turn to the solubility chart at the back of the booklet. In the 2020 version of the booklet, it's on page 148. There's a table of density values at the top of the page. So just recall from middle school science what density is. Density talks about how much mass you have in a given volume of a substance. So it relates those two things, the mass and the volume. When something is very, very dense, it means that it has a lot of mass squeezed into a little volume, a little space. You can calculate density using a simple formula based on that definition. Density is the mass divided by the volume, or D equals m over V. Now in this course, we're only going to use that formula if we're calculating the density itself. So the only time you'd write this formula down is if the question was asking you to calculate density. Then you would write the formula and you'd plug things in. When you look at the formula, we see that ratio, m over v, or mass over volume. That ratio is itself a unit multiplier, in the same way that you would say 1 inch has 2.54 centimeters. A density might tell you that you have 6.5 grams for every 1 cubic centimeter, for example. So because of that unit multiplier similarity, we're going to use unit multipliers to solve problems if you're trying to find a mass or you're trying to find a volume using the density. So this is very important to understand. We're not just interested in trying to solve the problem. What we're interested in this lesson is to set up the answer using unit multipliers. So that's the key idea here. It's not just about finding the answer, it's about using unit multipliers to do it. So let's jump in. The best way to use this video, if you're using it as a review, would be to pause and try the questions yourself. If you're doing it with me, you can also pause when you think you know what you're going to do and try it yourself as well. But don't just watch the video, otherwise that's not really going to help. So if you're doing this at home, have a piece of loose leaf out. You don't need to copy the question, but you can put your answers down on loose leaf. So the first question, what is the volume of a copper nugget that has a mass of 22.51 grams? And right above there, we're told the density of the copper metal is 8.92 grams per cubic centimeter. Grade 9 students, you'd find that density also in your data booklet, in your solubility chart at the back of your science booklets. So we're looking for the volume and we know the mass. So we're going to use that density as a unit multiplier. So let's start by writing down the mass, the number that we were given in the question. So we have 22.51 grams of copper. And just like any unit multiplier, we want to get rid of the grams, so we'll put the grams on the bottom of my multiplier. Then we're trying to find volume. When you look up at the density units, you see grams per cubic centimeter. So the units for the volume are going to be cubic centimeters. That's right. Now when you look at that unit multiplier, you see grams, you see cubic centimeters. So this tells us that our unit multiplier is actually the density that we were given up above. You don't need to write the word density every time, but in your notes, if you're doing this as a first example, that's pretty smart to do. So the density was 8.92 grams for every cubic centimeter. So we're going to put the 8.92 beside grams in our unit multiplier, and it's for every cubic centimeter, so for every 1 cubic centimeter. Now we grab a calculator, pause and try this yourself. So we're dividing 22.51 by 8.92, and we have to do a little significant digits thinking here. So the mass had 4 significant digits, 22.51. The density has 3 significant digits, 8.92. So we can keep 3 significant digits in the answer when we divide. So the answer will be 2.52 grams. Whoops, 2.52 cubic centimeters, not grams, right? The volume we were calculating. All right, so there's my final answer, set up as a unit multiplier. All right, so it's very, very important that you set it up in that way if you're going to try to get full credit in this course. The second question, what is the mass of a cube made of copper that has 2.3 centimeter for each edge? So if I'm looking for the mass of this cube, and it's made of copper, I'm going to use the density as a unit multiplier to do that. But we would need to have the volume of the cube, right, in order to use the density and find mass. We don't have the volume, but we have the length of each edge. So this is really a two-part question. The first part, let's calculate the volume of the cube. For a cube's volume, it would be length times width times height, or since they're all the same, we could just call those sides, and we could say cubed. S times S times S, or S cubed. So we get 2.3 centimeters cubed. Grab a calculator now. Think about how many digits you'll keep in the answer. You can only keep 2 digits in this volume. 2.3 has 2 digits, so the answer is going to be 12 cubic centimeters. There's the volume of the cube. Now that I have the volume, we can set up a unit multiplier starting with the volume, 12 cubic centimeters, and we could use that density again, but this time we want to get rid of cubic centimeters, so we put that in the denominator, and we want to find grams, the mass of the cube, so that goes in the numerator. The density was 8.92 grams per cubic centimeter, so we write the 8.92 beside the grams on top in this case, and that's for every cubic centimeter. Again, when you see that, grams and cubic centimeters in your unit multiplier, that's the clue that that's going to come from the density, the numbers for that. So we grab a calculator now, 12 times 8.92. We can only keep 2 significant digits. The calculator screen tells me 107.04 grams, right? The cubic centimeters canceled. But if you can only keep 2 significant digits, this will have to be rounded off to be 110 grams, or in scientific notation, 1.1 times 10 to the 2 grams. Notice how we learned significant digits in our first unit. Every calculation we do, we use significant digits. So it's not something that we learned and then forget about. All right, if you want, you can pause the video and try this one yourself. So we're told we have a 500 milliliter sample of oil, that's its volume, milliliters, and we know its mass, 450.0 grams. So as soon as I saw that it told me the volume and the mass, I could predict it's going to ask us to find the density, and that's what part A is telling us. Now remember, I said earlier that we're using unit multipliers to solve the problems. However, if you're going to find a density like we're doing here, this is the one place where we use the formula. So we'll write D equals m over v, mass over volume, and we'll put in the mass and we'll put in the volume. So the mass was 450.0 grams, 4 significant digits, divided by the volume, 500 with a decimal, so that has 3 significant digits, milliliters. Typically, the units for density will be grams per milliliter like this, or grams per cubic centimeter like we saw earlier, but in reality, the units could be any unit for mass per any unit for volume. For example, in chemistry, we sometimes talk about the density of a gas, and there it'll be grams per liter, usually. But in grade 9 science or grade 11 chemistry at the beginning of the course, we'll use grams per milliliter or grams per cubic centimeter, keeping in mind that 1 cubic centimeter is the same as 1 milliliter, right? Those are the same things, just different names. So we grab the calculator, 450 with 4 significant digits, divided by 500 with 3 significant digits. My calculator just says 0.9, but I have to keep 3 significant digits in the answer, so 0.900 and grams per milliliter would be the density of this oil. Notice that that answer makes sense because the density of water is 1 gram per milliliter, 1.00 grams per milliliter at room temperature, and oil's density is less than water, which means that oil floats on the water. So that density makes sense. It's less than the density of water. Part B, now we're going to use a unit multiplier. What is the mass in kilograms for a 20-liter sample of the oil? So it told us the volume, it's asking for the mass. This is the clue to set up unit multipliers. So we begin, if you think you know what you're doing, go ahead and pause the video. Whoops, wrong utensil. 20.0 liters. Now, the density was grams per milliliter. The volume units are milliliters. This volume unit is liter. So the first thing I'm going to do is convert my liters to milliliters, right? So that I have the same volume unit that was in the density. This is a simple recipe that everybody should know. There's 1,000 milliliters in a liter. Now I'm going to put another unit multiplier, and now I can use my density. I can get rid of the milliliters, and I can switch to grams. This, with grams and milliliters, is my density. The density up above said 0.900 grams, so we'll put the 0.900 beside the grams for every milliliter, so for every 1 milliliter. But the question didn't want the mass in grams. It wants the mass in kilograms. So we'll do one more unit multiplier. We'll get rid of the grams for mass, and we'll switch to kilograms. Looking at the units, liters cancel, milliliters cancel, grams cancel. We're going to get an answer in kilograms, which is what it asked for. The recipe for kilograms and grams, like milliliters and liters, everybody should just know. 1 kilogram has 1,000 grams. Now mathematically, you might notice that we have 1,000 in the numerator and we have 1,000 in the denominator. Those are just going to cancel out, all right? But on your calculator, if you'd like, you can include them. So you can say 20 times 1,000 times 0.9 divided by 1,000, and you'll get an answer of 18. But how many digits should we keep? Looking at the measurements, 20.0 liters had 3 significant digits. Our density has 3 significant digits. But the thousands, remember, those are perfect numbers. Those are exact numbers. There are exactly 1,000 milliliters in a liter. There's exactly 1,000 grams in a kilogram. So we ignore those when we do significant digits. They have infinite significant digits because they're exact. So because we have 3 significant digits in these numbers, we're going to keep 3 significant digits in the answer, and we'll write 18.0 kilograms. Part C, if you think you know what you're doing at this point, pause the video and try it yourself. So we have a 47.15 gram sample of the oil, and we would like to know the volume of the oil. It doesn't tell us what units, so we can use whichever units for volume we like. We'll just use the milliliters, which were the units for volume in the density. So we'll get rid of the grams, we'll convert to milliliters. When we see grams and milliliters together in a unit multiplier, that is our density. The density was 0.900 grams, so this time that goes on the denominator, for every milliliter. We have 4 significant digits in the mass divided by 3 significant digits in the density, so we're going to keep only 3 significant digits in the answer. 47.15 divided by 0.9. The calculator gives me this big long answer, but I'll round it off. 3 digits, 52.4 milliliters. Again, the importance of the answer is minimal, right? That's not the main thing. What's important is that you set up your answer like you see here, using unit multipliers, making sure your units are clearly visible, paying attention to significant digits along the way. I hope you're feeling like you're understanding this. A few more questions. Number 3, if you think you know what you're doing, you can pause the video and try it yourself. We have a cylinder made of lead, 8.25 inches, that's what the IN means, inches tall, and a diameter of 2.04 inches. As soon as I see inches, I know I'm going to have to do some unit conversions probably. The density is given as 11.4 grams per cubic centimeter. Notice the volume there is per cubic centimeter, while we had inches in the 2 dimensions. The first part of the question says, what's the volume of the cylinder? And express the answer in cubic centimeters. Now, is this a density question? Well, if it were, if I was going to find the volume using the density, I would need to know the mass, right? You can only find the volume using a density if you have the mass, and then we could use a unit multiplier. We don't know the mass, so this is not about density, this is not about unit multipliers. Instead, this is a basic math question. If you have a cylinder and you know its height and diameter, can you find the volume? Now it wants the volume in cubic centimeters, so I'm going to just start by converting the two numbers from inches to centimeters. So there's the height, 8.25 inches. With one multiplier, I can convert inches to centimeters. There's 2.54 centimeters in 1 inch. So 8.25 times 2.54, this is going to be, let's see, 20.955, so round it off to, we can only keep 3 significant digits, we'll have to call that 21.0 centimeters. Right, there's the height. The diameter is going to be 2.04 inches. And just like we did above, get rid of inches, convert to centimeters. 1 inch is 2.54 centimeters. 2.04 times 2.54, the calculator says 5.1816. We can only keep 3 significant digits, so we'll call it 5.18 centimeters. Now we know the height and the diameter in centimeters. The formula for volume of the cylinder, though, we don't use the diameter, we use the radius. So let's calculate the radius. The radius is 1/2 of the diameter. So it's going to be 1/2 of the 5.18 centimeters. So divide that answer by 2 and we get 2.59 centimeters. Now we have everything we need to find the volume. We just write the formula for volume of a cylinder. The cylinder has a circular base. The volume formula is area of the base times the height. Because the base is circular, its area is pi r squared, and then we multiply by the height. So 3.14 times 2.59 centimeters, the radius, squared, times the height. And we can keep 3 significant digits in the answer. So on my calculator, I get 442 cubic centimeters. Okay, so in my answer, I started by converting the height and diameter to centimeters. Somebody else may have simply used the formula V equals pi r squared h and found the volume in cubic inches. Then they could have converted cubic inches to cubic centimeters. If you chose that path, which is perfectly fine, keep in mind that your units are then cubic. So you would have to use the unit multipliers not once, but 3 times to convert cubic inches to cubic centimeters. So you'd be dividing by 2.54, you'd be timesing by 2.54 3 times, not just once. The next question says, what's the mass of the lead? So now we have the volume, we can use the density from up above to get the mass. So we'll use a unit multiplier. We'll start with our volume, 442 cubic centimeters. We'll get rid of the cubic centimeters, and mass is measured in grams. So this grams and cubic centimeters, this is density. The density of the lead was 11.4 grams per cubic centimeter. So 11.4 grams for every 1 cubic centimeter. We can keep 3 significant digits in the answer. So the calculator ends up saying 5,038.8, but we can only keep 3 significant digits. So we can call it 5,040 and don't put a decimal at the end, or we can switch it to scientific notation, 5.04, a number between 1 and 10, and then times 10 to the power of 3, because we had to move the decimal 3 places to get 5.04, and that'll be grams. So you notice how we're using the things that we learned in our earlier units. That's going to continue throughout the course. Significant digits, scientific notation, unit multipliers. All right? Pause the video and give this a try. So this brick of gold, be nice to have this brick, has a mass of 2.0 kilograms. The density of the gold is 19.3 grams per cubic centimeters. Did you notice right away the density uses grams, but the mass we were given was kilograms, so my head tells me I'm going to have to convert those units. We're looking for the volume in cubic centimeters. So given the mass, we're also given the density. That means we're going to use a unit multiplier. So we take our mass, 2.0 kilograms, we convert the kilograms to grams, and then we use the density to get rid of the grams and convert to cubic centimeters. Notice that I never start my unit multipliers with the density. The density is the unit multiplier, so it gets used later in the setup. You'll never begin the unit multiplier using the density value itself. So the recipe is that there's 1,000 grams in a kilogram. The density of the gold was 19.3 grams, so we'll put 19.3 beside the grams for every cubic centimeter. Okay, how many significant digits can we keep? Well, 2.0 has 2 significant digits, and the density has 3 significant digits. The 1,000 again is a perfect number, so we can ignore that. So we're going to keep just 2 digits. So 2 times 1,000 divided by 19.3, and keeping only 2 digits, we have a bit of a problem. The calculator says 103.6269, etc., but we can only keep 2 digits in the answer. So there's only one way to write that number using 2 significant digits. We'll have to switch it to scientific notation. So we'll call it 1.0, there's my 2 digits, times 10 to the power of 2 cubic centimeters. There's the volume of that gold brick. And now one last question, multi-part. Pause the video and try this yourself. A 2-liter sample of alcohol has a mass of 1,578 grams. What's the density of the alcohol expressed in grams per milliliter. So did you notice the volume was given in liters, but we want milliliters in our density? So let's begin by converting the 2 liters using a unit multiplier. Switch the liters to milliliters. 1,000 milliliters in a liter. So we get 2.00 times 10 to the 3 milliliters. If you just wrote 2,000, that's okay, but keep in mind you need something with 3 significant digits. So there's only one way to really do that with the number 2,000, and that's to put it into scientific notation. So now we want the density. When you're calculating density, this is the only time where we use the formula for density. So we'll say density is mass over volume. Be sure you write the formula. And now let's put our numbers in. The mass was 1,578 grams divided by the volume, which was 2.00 times 10 to the 3 milliliters. Now on your calculator, if you know how to enter scientific notation, I hope you do, you can go ahead and use that. Or if you find it easier, 2 times 10 to the 3 is 2,000, so you could just divide by 2,000 on the calculator. 1578 divided by 2,000, we get an answer with how many digits can we keep? Well, 3 digits. The mass has 4 digits, the volume has 3 significant digits, so we can only keep 3 digits. 0.789 grams per milliliter is my density. So the only time you'll write that density formula and use the density formula is when you're finding a density like that. Okay? Question B, you need 50 grams of the alcohol, but you only have a graduated cylinder, which of course measures volume. So what volume should you use? Pause the video and try that. We know the mass, so we'll start with the 50 grams. And to convert to volume, we use the unit multiplier and we use the density as the unit multiplier. 0.789 grams for every milliliter, and we can keep 3 digits in our answer. So we get a 63.4 milliliters is the volume that she should measure out with the graduated cylinder. And the last question here, this one's a bit of a unit difficulty. You have a volume of the alcohol with a volume of 5.0 cubic feet. That's irritating. And we want to know the mass, right? So the cubic feet is irritating because our density is in grams per milliliter. So we're going to have to convert the 5 cubic feet into milliliters. So let's just start with that. 5.0 cubic feet. Now it's cubic feet, so we're going to need to use the multipliers not once, not twice, but 3 times, right? So we'll get rid of the feet and we can switch it to inches. But because it's cubic feet, we need to do that 3 times. Now we have cubic inches. Feet times feet times feet is cubic feet, and that cancels with the cubic feet out front. Next, we can get rid of the inches and we can convert it to centimeters, but there are inches, 3 of them, so we need to do this 3 times. Convert to centimeters. Right? Inches will cancel, and we now have cubic centimeters. Now you could just stop there and remind yourself that a cubic centimeter is the same as a milliliter, or we can get rid of cubic centimeter and just switch to milliliter. Okay? Don't write cubic milliliter. Milliliter is already a volume unit. Right? So this cubic centimeter will cancel with the 3 centimeters there. Centimeter times centimeter times centimeter gave us cubic centimeters, which cancels here. So now let's put our numbers into these recipes. There's 12 inches in a foot, 3 times, 2.54 centimeters in an inch, 3 times, and that last unit multiplier is basically just a 1-to-1. 1 milliliter is 1 cubic centimeter. So now we're going to get our answer for the volume in milliliters. 5 times 12 times 12 times 12. Now you may have simply written this unit multiplier and put a cubed beside it. You could have just said 12 inches in 1 foot and put a cubed outside the brackets like that instead of writing it 3 times. But in grade 9, I usually suggest people write it out like this so that they don't screw that up. And then we multiply by 2.54 3 times. We get a really big answer, and we can only keep 2 significant digits. 5.0 had 2 digits, so I'll call it, let's see, 140,000, which has 2 significant digits. So now that we have the volume in milliliters, we can answer the question. 140,000 milliliters. The question was, what's the mass of the alcohol? So we could use the density, getting rid of milliliters and switching to grams. The density of the alcohol was 0.789 grams for every milliliter. So multiply 140,000 by 0.789, and we get 110,000, again keeping only 2 significant digits in the answer. And that will be grams, which is the mass that we were trying to find. All right, so I hope that helps. You've practiced and hopefully understand how to set up density problems using unit multipliers. You understand the only time to use the density formula is if you're calculating density itself, and you know how to pay attention to significant digits, scientific notation as well. So good luck. This should give you a good start or a good review. You can jump in and start your worksheets on density if you're